Good afternoon. Can you guys hear me? Okay, just gonna check our sound here. All right, so I'm gonna talk today about making musical instruments on iOS. Gonna start by going into how sound works at a basic level, and then how we do some low-level creation of sound with core audio. And then I hope to take you from making some simple noises to actually making an instrument. And then at the end, I'm gonna touch on some functional programming techniques applied to music. Just gonna scratch the surface of that. So in 2010, I made an app called Polycord. It's been an Apple staff favorite, a top 10 app in the music category. And I've got a little demo video here of what it looks like. So this is from version 1 on the iPad 1. So that's Polycord. So I'm going to step into the basics of sound. And what is sound? Well, if we had a gong and we hit the gong would vibrate. And the vibrations would cause pressure waves to be created in the air. So it would cause these waves of pressure that eventually hit our ear. And our ear is equipped to turn these waves of pressure into what we hear as sound. So we can make a record of the vibrations that we've heard. And you've probably seen a waveform on a computer before in an audio software program. And what that is measuring or displaying is the pressure wave. So it has points of high pressure and low pressure. And when we talk about samples, we're talking about one point of that wave at some moment in time, some value. So we can recreate these vibrations with a speaker. We'll hear the sound again. And basically, at the high point of the wave, we can push the speaker forward. At the low point of the wave, we could pull the speaker back, and that creates the low pressure point. And then if we just instruct the speaker to vibrate exactly the same way that the gong did, we'll hear it exactly the same way. So samples are measurements of this pressure wave over time. And core audio basically just wants streams of these samples. So core audio can be kind of difficult. It's got a bad reputation, but really it's kind of simple at the lowest level. It just wants these samples. And the way it works is that while core audio is playing these samples to the speaker and pushing the speaker forwards and backwards really fast, thousands of times per second, you're supposed to be writing the next set of samples that it's going to send to the speaker. So another way to look at that is that core audio is playing on the right, and then on the left, you're basically just writing samples to some audio buffer, which is just this array, and you're just putting values in there. And making sound is just writing samples to that array. So throughout this presentation, I'm going to show little snippets of code, but a lot of this is on GitHub. And you'll be able to download that and play with some of this. Most of it, well, pretty much all of it's based on the amazing audio engine. So this was developed by the developers of AudioBus, which you might have heard of. And it makes core audio pretty simple. It takes a lot of boilerplate out, and you just provide a block that writes samples to an array. So what would that look like? Well, this creates white noise. It's just random samples written to the array. And that might seem kind of boring, but it's also kind of exciting because we've made sound with very little code. But meaningful sounds cycle. So what do I mean by that? Well, let's think about sine waves. Sine wave is something that cycles. It goes from 0 up to 1 to -1 over and over again. If we look at that in a different way, over time, we see that it draws a wave. So we've already looked at waves, so this is another kind of wave. And if we were to draw this wave, if we were to put those values in our sample array over time, we'd get a tone. And it's not much more code than the noise that we did. And the tone that we get has a pitch, and the pitch is the frequency. So that's how fast that sine wave is cycling. So really, it's pretty simple. We're just cycling values between 0 and 1 and -1, in this case 440 times a second, and we hear concert A, which is the A above middle C on a piano. So to illustrate that, lower pitch sounds are slower waves, higher pitch sounds are more frequent. So we're really just drawing patterns of sound into a buffer, and we can hear them. But we want to build instruments, and instruments shape sounds. So we have our white noise from before, and we could shape it in a really primitive, basic way. Basically just create a switch where we could turn the noise on or turn it off. So in our view controller, we could have a property called key down. And now, one aside is that core audio really doesn't mix well with Objective-C. That's one of the things that makes it a little tricky. So you don't want to be using the Objective-C runtime in that block where you're generating samples. So one of the things you can do is you can expose, in this case, the key down property using @public. That'll allow your core audio code to access that variable directly. And I'll show you in the next slide here. So instead of doing VC for view controller dot key down like you're used to, or sending that as a message, you can use the dereference operator. That'll get the instance variable directly. So you're not using any Objective-C there. It's sort of an aside, but it's kind of important. So basically what we're doing here is if the button is not pressed down, we're writing zeros out to our array. So zeros is going to mean no sound. So now we have a very, very basic instrument. It's not a violin, but it's it's kind of cool. So, and you can download that off of GitHub and look at that. It's not very much code at all. So we want to shape sound in even more interesting ways than that. And envelopes are something that shape sound. So to understand what an envelope does to sound, I'm going to tell you about amplitude. And basically all amplitude is how far our values can deviate from 0. So if our values can go all the way up to 1 and down to -1, that's going to be full volume, full amplitude. If they can only go halfway, up to 0.5 and down to -0.5, it's going to be half amplitude. It's going to sound half as loud. So an envelope changes amplitude over time. A common envelope that you've seen in synthesizers is the ADSR envelope. So it's got an attack phase. So the attack is how long it takes to get to full volume. Then it has a decay where the sound gets a little bit quieter until it reaches a sustain point. So the sustain is if the key is down on the synthesizer or the violinist is bowing the violin, it's going to sustain at that volume, and finally you have a release phase. And that's how long it takes to completely die off. So we could visualize this as taking our raw noise, piping it through this envelope component, and then at the other end, we're going to get shaped noise. So we're going to make an object, our ADSR envelope generator. And I'm going to create this abstract class first, because it's something we're going to kind of use throughout making an app. We want to build these little components that can be put together, kind of like Bill was talking about this morning, to build a more complicated, complex system. So a generator, as I've called it here, is basically just something that has a block. It defines a block that takes a timestamp in core audio time, a number of frames that it's going to process, and then the pointer to the audio that it's going to write to. It exposes that block so that we can get to it at a low level. And it's got a scratch buffer so it can do some of its work before writing it out to our actual finished array. And it creates a property so that we could copy it and do our memory management correctly and all that. And so what's happening here is all the magic is in that block. The header file is very simple. It just has this block, and core audio is only going to know about that block. So all the implementation details are encapsulated in that block, and we don't have to deal with Objective-C in core audio, but we still can talk in terms of objects and get that richness that we want. So at a high level, we have user interaction, objects sending messages to each other, and that's kind of the app layer that we're most familiar with. And at the low level, core audio is just calling our block. And everything's encapsulated in that block. It doesn't have to know about the inner details. So we can extend that basic abstract idea of this component that writes samples and adds a few properties to it for the attack, decay, and release. And if we call the envelope, the ADSR block, right after we generated our white noise from earlier, it's going to shape that white noise. So now we're going to have two different shapes to our noise. We're going to have one that's more of a smooth shape to it, and one that's more of like a hi-hat closed on a drum set, and that would sound like this. So hopefully you're starting to see that, like, with just some white noise in an envelope, we're creating some variety to the sound. So now I'm going to play a richer, more interesting sound. This image is of an Indian drum vibrating. And this drone, I created kind of by accident. I found this in a paper online, and it showed the harmonics of this tone. And that sounds complicated, but really it's just a bunch of different sine waves at different frequencies added together. And it creates this kind of awesome primal sounding drone. So to illustrate that, if you look at this sample app, and again, all these are on GitHub, we could turn up different parts, different waves. So we have the bass wave, kind of low frequency. We could add in another one that's 3 times as frequent, another one that's 4 times as frequent. So it's got more richness than just that basic sine wave that we saw earlier. So recently I got interested in what's been going on in the closure community. There's a project called Overtone, and it's pretty interesting what they're doing. They're making music using Lisp, basically, and they're applying the concepts of functional programming to music. I found a library called OC Totally Lazy, and which was really easy to start using to generate lazy sequences, and it provides a bunch of functional programming extensions to Objective-C collection objects. And lazy sequences are cool because you could start to think in terms of like infinite sequences, like all integers that exist, but you only get, you know, the next ones that you need. And the way they do that in Overtone, or the way they make use of it, is for things like scales. So we could define the Ionian sequence, which is like the major scale, as a series of steps. So 2s are whole steps, 1s represent half steps, and if we looked at that sequence on the piano, so you see it goes 2 steps, which are whole steps, and then a half step, and so on. So what we could do with some functional programming ideas is apply something like rotate. So this will do this. It's easier to just illustrate. So we've rotated the list, just like this really simple operation. But what we get out of it is a totally different scale. It's now the Dorian scale. And that's really simple, but it kind of blew my mind because I thought, wow, you can do with simple lists all of this, you know, musical, interesting stuff. So in one of the last sample projects I'll show, you'll find a class that has some methods that I've put together where I basically ported some of the Overtone code to Objective-C. Probably didn't do that great of a job at it, but it's something you could build on. And so we've talked about a bunch of things, and maybe it doesn't seem like we have that many techniques, but we have enough to make a basic instrument. So I'm going to end today with the sample project that I made that combines everything we talked about, that you could download. It's MIT licensed, so you could put this in the store. Also, dots, right? We saw dots earlier today, so my idea was like to make it look like that. And basically, this is a drum app. That drone tone that we heard earlier is shaped, And the library of musical functions that I talked about is used to create a different set of scales for this to play. So this can be built with just a couple of things we talked about today. I hope you download it and check it out, and I'm excited to see what you might make with it. So, thanks.
All right, thanks a lot.
Sure.
That was really cool. If you give us just a moment here, since we have demos from both guys, we have to switch Macs this time.
All right. Let's see. It does.
Okay, next up is Rhyne, who got a little tired of doing business presentations and decided to do something cool instead. So, and wasn't sure about what he's doing, but I'm interested to hear how it's going to go. And because everything Rob does up here has always been really cool. So, how's that coming there?
Doesn't like the clicker. Okay.
All right.
Seems to be.
So Rhyne.
Can you guys? There we go. Okay. All right. So thanks, Tom, and thanks, Tim, for taking a chance on this. When he asked me to speak again this year at Renaissance, I told him I didn't want to do the same old business talk that I seem to do a lot of. Because, you know, being the CEO, you should be able to do something fun now and then. I mean, after all, it's your business. So I'm really excited to talk about what we're going to do. It's not quite as cool as what you just saw. I'm not going to be programming music as so much I'll be programming music. But using an old standard that's been around for years and using a different tool set, not necessarily writing the code. But I wanted to start with this from Apple that they did last week. I did not know they were going to do something like this before my talk, but it's very relevant. I broke the rules. So this talk was supposed to be about making music on iOS, and most of what I'm going to talk about today is actually using the Mac. And when you look at that timeline that they created over the 30 years of Mac history, you see artists pushing the limits of what their craft can do. And for a lot of people in the audience, I think you guys have the spirit of people who like to make things, but probably think of your computer as an Xcode terminal or an IDE or something that you inject code into. But there's a lot of creative things you can do with a Mac. And it's out of this that I kind of spun off. I mean, I run a development studio. Why on earth would I get mixed up making music? But when you think about applications and the types of things that we need to do to launch successfully an application, there's a lot more than coding. And today, at the end of the presentation, I'm going to show a trailer we created for a game that Jeff had hoped to talk about at this conference, but unfortunately couldn't make it. So everybody will get to see the first peek of at least some of the backstory of the game. We're really excited to talk about it, but the main vehicle for that is I composed all of the music for it. So I'm Rob. I'm Captain Taco on everything social and that stuff if you're looking for me. And you may recognize me from my past movie roles. I was in the 1995 film, Rob Roy. But what I want to talk about today is the impact of music. And so when you consider mobile computing and what the iPhone did for traditional computing, Mac applications, is that it brought a second sense to bear when you're using an application. You know, you really couldn't touch something. You would see something and interact with what you were seeing. The mobile device added touch. And just adding that simple second sense to everything, it made software more tangible and more real. In the same sense, audio and something that goes into your ear can add an additional sense. A lot of people think of touch when they think of mobile devices, but often in these mobile devices, they also have headphones on. And so you can be in their ear as well as being something they can touch. And so when you're thinking about marketing and doing some of the other things, you want to consider this. I've seen a lot of app trailers or teasers, or they want to explain what their app's doing, and they create a video, and it probably looks something like this. This is a video that we created ahead of the launch of Briefs. This was a video that Mark Bosco worked on. He's going to be talking about this as part of his presentation in a couple days, so I'm not going to go into too much about it, but you can see we took live action footage. There's some rotoscoping to get some of those images on there. It's very fancy, but it's lifeless. There's nothing there. This isn't what we put on our site. Now here's the same video with sound. And what you can immediately hear is it's more interactive. You're more engaged. There's music, there's spoken word. It's reaching into your sensibilities. It's reaching into your multiple senses. And what's really fascinating about audio, and this is something that I have to credit Daniel Steinberg for, is that there's a lot of things you hear that you're not even aware of. That audio and your audible sense is actually stronger than your visual sense in a lot of ways. You can gain more context. So if I take that same video and I play just the audio from it, you'll get more out of it than you did when it was just the video and not the audio. You're engaged. It's raising your heartbeat. You're focusing on it in a way that you wouldn't focus on it when it's blasting at you. And so sound is really important. It's an important part of how your app works, and it's an important part of how you market your app. And so I believe sound is really important, and that's kind of what brought me here, and that's what I want to talk about. And anybody that knows me, I love film music. I love film scores. So when we were talking about writing music and doing some of the music for our trailers, like what you heard in the earlier video with Mark, that was actually something we bought from Premium Music. What I really wanted was this orchestral sound of film scores, like what you heard. And the question I always thought is this possible for us to do this? I mean, it requires a live orchestra. That's 80 plus people that you have to pay. You have to sit in a recording studio. You have to record that. Then you have to edit it. Then you have to master it. And that's quite a bit of money. And what I want to know is it possible for me to do that? Could I do all of that? Could I do it all on my computer? And it turns out Batman's a great example because the man who wrote and performed a lot of Batman is this guy. I skipped a slide. Hans Zimmer. And this is from the timeline, that Mac 30 timeline that we talked about earlier. And he has this great quote that says, "I wouldn't be a composer without the Mac." He's not classically trained. He's not able to perform all the different instruments that he plays, but he uses his Mac to create all of this music. And so that's kind of the approach I took towards this. Could we take the Mac and turn it into a programmable orchestra? And I say programmable because a lot of what I'm going to show you uses a lot of concepts and a lot of the same techniques that you would use programming. You basically bust something out on a keyboard, you go in and edit, refine it, you can edit dynamics, you can trim notes, you can align things on measures. I was no longer limited about my ability to play something. I could just get it close enough, and then I can go in through software and edit it to get the exact sound that I wanted. I don't know how to play all these different instruments. I'm a percussionist. I don't even know the concept of needing to breathe in between notes. So the programming language that I use for this is MIDI. And MIDI is a 20-plus-year-old protocol. Most of your computers, all of your Macs have a MIDI output through the USB. You can plug a USB MIDI device directly into your computer, and Core Audio will automatically recognize it. So you could use some of the techniques you saw earlier to build your own instruments or input your own technology, but there's also a series of apps that are built around this. The centerpiece of any of your apps, the IDE of building software on the Mac, is what's called a digital audio workstation. And what I used for the music that we're going to play later is Logic Pro. And Logic Pro 10 also comes with a neat little app called Logic Remote, which is actually really handy. I didn't realize at the time I bought it. I bought Logic, I was using it, and then on a whim, I downloaded Logic Remote to play around with it. And what's incredible about it is when you're on an airplane or in a place where you can't haul around this big MIDI keyboard that I have, I can get notes out. It's not pressure sensitive, it's not perfect, your dynamics are usually off, but again, as I'll show you, you're going to be able to go in and edit that later. So it's a great way just to get some things out. Logic Remote is also interesting too, as I'll show in the demo. I actually use it when I'm trying to think about chord progressions. There's the chord tool in Logic Remote that's also in GarageBand for iOS, that you can select a key signature and it'll give you keys that, using the circle of fifths, naturally pair up with it and just sound right. So even if you're not musically inclined, you don't understand music theory, you could still play around and get something working. And hopefully, if the demo gods permit, I'll be able to show that to you. But where the real magic happens is, can it sound real? MIDI music for 20 years has not sounded real, it's sounded synthetic. And there's this company called Native Instruments, it's a German company, that's built an SDK for sound engineers to create sounds that sound breathtaking. All of the music that I'm going to play later was plugged in was sent out through this plugin. This wasn't something where I recorded musicians and then cut it later. I actually sequenced all of it in MIDI and then output it through a series of patches through Native Instruments. And the set of patches that I use is by this awesome group in Britain called Spitfire Audio. Spitfire Audio was founded by professional sound engineers, guys who build music for movies. The kind of stuff that I want to do, the kind of stuff that I was into, and they built a series of patches, including recently they just released a set of patches that they participated with Hans Zimmer and basically took a lot of his techniques and baked that into these plugins. So really, I didn't want to get up here and just show you a bunch of slides. I really wanted to jump into a demo and show you this stuff because I think it's more neat to see it than it is to hear about it. So bear with me while I switch for a second and plug in my mouse. I'm going to mirror my display. Hopefully you'll be able to see it. Okay, great. I don't have all the little minions running around flipping all these things like they do with those Apple presentations, so you have to bear with me. So this is Logic right here, and I've created a sample project that we're just going to go around and we're going to kind of do what's called busking. It's just, I'm just going to doodle around and kind of play something. I have no idea what I'm going to play, and it's probably going to sound terrible, but it'll give you an idea to kind of see how this works. And so like I said, I'm using Logic Remote, so I'm just going to plug that in. I'm using a wired connection so that I can get guaranteed networking and not go through the Wi-Fi to sequence this. I'll give it a second to connect. And now what I have is I'm kind of, I'll kind of just show this to you guys. I've got this chord tool, which is a set of white bars. And as I run through these white bars, you start hearing music. It's getting outputted through these plugins. And what's happening is I've set up a software instrument in Logic. So if you go in here and select this, I have that contact plugin that I talked about. And then I have this rack of different instruments that I've created. And they break out all their samples. These samples are huge. We're talking 30, 40, 50 gigabytes of data for some of them. The Hans Zimmer percussion library that I talked about is over 200 gigabytes. So this is something that I hope one day will be in iOS, but there's a long way to get there. But they have these series, and they have different things that you can do. It's really fancy what you can do with this stuff. They have different articulations. I'm showing the long articulation here, which means that when I hit a note, it will sustain that note. They've also recorded articulation so you can do short notes like staccato or pizzicato on some of the bowed instruments. And what that allows you to do is just get that precise kind of bounce and the sound dynamics that you want for that particular articulation. In this, I'm using longs because they're easy to edit. And I'm not that great at this. I don't really perform live. I'm more of a recorded guy. So this is the plugin I have here. I have 3 tracks that I'm running here. One for woodwinds, one for strings. And when I switch these tracks, the instrument will basically switch. So this is, you can kind of hear a woodwind choir, low bass clarinet, bassoon. Can you guys hear that coming through? Is that coming through enough? All right. Goose it some more. And then the same with strings. Yeah, there you go. You get that rich cello sound, bass sound. And what's amazing about this is, again, this is all fake. It's recorded samples of actual musicians performing this, but all this is doing is sending a digital signal through MIDI, and then Logic is using the plugin to output what you actually hear. And so I'm just gonna play something real quick to kind of give you an idea, show you how you edit it. So I'm gonna go back into the brass. I'm going to hit the record. You're going to hear it. A metronome's going to beat off 4 beats because we're in 4/4 here, and then I'll kind of just make something up. musical sense, but it'll give us an idea of what we can do. Now, immediately you'll note with the metronome playing, I was playing off the metronome, which is pretty bad for a percussionist, but I'm speaking, so I've got normal nerves. So what we're going to do is I want to select this clip that I created and go into the editor to kind of blow this out. And I want to show you how you can edit some of this music once you set up. So you'll see I didn't start directly on the downbeat. I hesitated. And so what I can do is I can just grab these 3 chords right here, and I can just slide them over, and it'll snap to the opening. Likewise, I didn't sustain all the way through the entire measure. That's poor performance right there. So I can just grab these, grab the edge, and if you've used Final Cut or Logic or any type of editor, you'll recognize this. I can just grab this and just extend it out. So now that note will sustain. So I can go back and I can play this. Well, no, it's not. Oh, it's messed up. Pro tip. If you go, a thing about MIDI that you just saw there, I'll actually explain the mistake because this was a frustration point for me. Because these are sustained notes, when you go to play, if it doesn't see the attack of that note, it'll actually be silent when you play it unless you pull it out. So what happened is I dragged it over the edge and it didn't play. So let's try that again. So now it's connecting. So now you'll see some other mistakes where I kind of grab some stuff there. I want to connect these. And again, this is just like code. I just laid it out, I threw it down there, and I just want to connect this stuff out. I can change the pacing. I can change the notes. I can drag them up and down. Earlier in the presentation, they were talking about overtones and semitones, these kind of whole steps, +2 steps, +1 steps. So you can go in Logic, and you can say, you know what, I want to drop that down a key, a whole step. I can change it again. I can drop it more. I'm holding Option and arrowing down. If I hold Shift and I hold Option, I can jump an entire octave up and down. There's a lot of other cool things you can do here. You can change the velocity. So I have a very strong attack for these. If I want this to be a soft attack, I can just drag this velocity down here. And then when I play this again, it's a little softer. It's tough to hear. So you can kind of change the attack and you can play things. If you're musically inclined and you can read sheet music, you can also look at this stuff and you can see how bad off beats I am looking at these things and interpretations. But what I'm trying to get across here in too much is it's very malleable. It's not based on your musical ability necessarily. You can go and kind of hack at this and then get something pretty close. If you understand the mathematics of music, but you don't necessarily understand the performing part, Logic is just for you. MIDI is great for that because you can go in and look at this stuff and say, I want to hold this note for precisely this amount of time. They have gridding and things like that. You can change the length of notes. So I can make this a quarter note. I can make this a 16th note. I can make it an 8th note. I can also cut and paste here. So if I hit C, I move my, or Command C, and then I hit it there. Now I have 2 8th notes that I could play. So kind of sounds funny because I have that long articulation. If I wanted to change the articulation to short, I would get a much crisper sound. So I don't want to do too much on that just because I could sit here and play with this for hours and you guys would be bored and I would be having a good time. So what I want to show you is that I actually used this over the past couple weeks and we've been working on this trailer. All right, do your thing, switch. Logic will do this from time to time. It's, anytime you unplug your headphones or you switch inputs or you switch, it's got to re-go. It goes through it, it's going, and I guess it's validating all your plugins. I can't really speak with authority what it's doing. So Logic in particular for scoring films, it's pretty nice. You can take a pre-existing video, you can put it in and it'll go in and pre-detect all of the cuts in the film. So a lot of tying music and film, you actually want to time musical changes, so a tempo change, chord change. You want to time that to an actual cut in your video. And by connecting those two things, you're basically bombarding the viewer with two things at the same time. They're seeing a visual change and they're feeling that audio change. And so it actually makes them feel more engaged. So you do this by going in and putting these markers. I have a couple markers in here. You get a kind of an idea for the dialogue of the trailer that we put together, where I'm actually tying those to voiceover cues. This is a little more complicated project than what I showed you before. I started with something simple. In here I have 2 voiceover tracks. I have my scratch audio that I created for voiceover, and then I have the professional voice actor that we hired that actually sounds good. And again, you're putting these ideas out there because you just want to scaffold and you want to line things up. A lot in the same way you would build an app or you would design an app. It's like, just get something out there that works, and now let's massage it and play with it. So like I said, you can also see the video track. In theory, you should be able to visualize the cuts. I've had a little hard time with that. I found you can't zoom in quite the way you want. What I ended up doing is I would flatten this file out, take it back into Final Cut Pro, and I really did the video editing after I had the final audio. I've seen online where a lot of people can actually do that lineup, and they can affect the music in Logic. Maybe I'm just not musically talented enough for that. Remains to be seen. So we have our voiceover, we have our winds section, woodwinds and brass, we have strings, and of course we have percussion. And I am a percussionist, so I want to play some of this percussion stuff, because that's really, for me, it got really cool. So one of the opening notes we have here is this bass swell that's just, our trailer's in space, so we wanted to have, I'll make that full. Gotta find the note, give me a second. Just hunt around. This is what you get. All right, so here's our swell. Another thing I'm doing here, this yellow region below it, is actually, it's controlling the modulation. The Albion plugins are actually set up so that you can use the mod wheel, which is that, you've kind of, most MIDI keyboards have those 2 wheels. They have one that'll kind of bend the pitch, if you want to sound like Moby, and then you've got, something just to the right of that. And that's actually one that that'll actually hold its place as you move it up and down. And that's called a modulation wheel. And what the Albion plugin allows you to do is you can control dynamics. So how quiet or how loud you're going to play based upon that modulation. And so, again, because it's MIDI data, you can go in and you can affect this. So if I wanted to affect a crescendo on either side of these, if I want to drop this down, make it louder, make it softer, I can create additional control points in here. If I want to bring it up and down like that. There's a bunch of things you can do. And the point of this is there are analog devices you can plug into this, or even analog digital equivalents of analog devices. But once all of it is into Logic, you can manipulate this and you can control it later. Some other neat little percussion notes we have here. We have these large drum hits to say, to warn of ominous things. There's a series of Easter Island drums that's recorded as part of the Albion package that I use to great effect. They sound really good, be real punchy. And then from Zimmer's package, again, let me get my playhead where it needs to go. He had these taiko ensembles. So how many of you guys watched Battlestar Galactica? The Ronald Moore version. Okay. If you've listened to the score, it's written by one of my favorite composers, Bear McQuarrie, and he uses those drums. You'll hear them, those kind of like real rhythmic drums. They're called taiko drums. They're an Asian ensemble drum that individually they sound interesting, but a lot of times they're played by 7 or 8 percussionists in a group. And a lot of musicians like these days. They're real popular. Bear McQuarrie wasn't the first. And this is one of those things where I think is amazing how the technology has progressed and what they can sample. Because they can't just sample an individual instrument, they can sample that ensemble sound. And they do different things where they do what's called a round robin, so that if you don't want, when you have 10 percussionists all trying to hit a note at the same time, it's not going to happen precisely at the same moment. And when it does, you'll hear a little dirt on that. And if there's a larger space, you'll actually hear this kind of, this thump almost to it. And it adds more drama because it adds a human element. If they all hit it precisely at the same time, it's a dead giveaway, it's a machine. And so in these ensemble recordings that they did with these taikos, it's really incredible because I can just sequence those notes when I want them to hit. And I have a couple keys I can use on the keyboard and I can kind of bang on them. And it's fun, but they're also adding that extra element where there's that imprecision that you get with human drummers. So I've been grabbing this area a lot recently. This is something when you're reworking a particular section and you want to see a given section, you want to play it over and over. You could set this on a repeat. You kind of select that band up there, you select that yellow region, and it'll just keep playing that region over and over. If you're not interested in working on a particular section, you lose your sanity. But just to give you a feel for that, it'll one of these notes and say, you know what, this note actually needs to be articulated a little more. Then I play it again, and then I can follow the cursor. So that's basically logic. I think if I go too much further, I'll just lose all of your attention, and you guys will fall asleep in a coma. If you guys have questions about this, I'm kind of, just shooting a water hose of stuff at you. Feel free to ask me questions afterwards. I'd love to talk about this. And if you saw that I'm doing something terrible and you're like, Rob, I've got a great way for you to fix your problem or stop doing this, please tell me that as well, because while I can speak with authority on a lot of subjects, I am definitely a novice in this, which is really why it's so much fun. So if you guys are interested, I want to close out by talking about the trailer. And if it's okay with Tim, I'd actually like to show the trailer if there's interest there. All right, I heard one. That's enough for me. I mean, honestly, my ego needs it. Okay, so, oh, right, I got to plug back in this. Right. Okay, hopefully it won't. Aha. Okay, so to give a little bit of setup, because again, Jeff was supposed to talk before me and would talk more about the premise of the game. Republic Sniper is set in a universe, a much broader universe than the game itself. We originally came up for this with this story. If you've read some of Jeff LaMarche's blog posts on his website, you know that we have about a 300-page story Bible. And so ahead of the game, we wanted to do a trailer to kind of set the key events into the universe so that they really are not necessarily relevant to the game, but they inform the intentions of some of the characters and also just kind of set the mood. And so we originally started it started like, hey, it would be great if we do this 30-second trailer. And then the 30 seconds grew into a minute, and they grew into a minute and a half, and now it's almost about 2 minutes. So you'll have to bear with me on this, but I think it's worth it. And this was probably the most fun I've had professionally in years. I mean, I love my team, but it's really, this is so new to me, and this is something that is so different from what I do programming, even though there's similarities, that I just had a ton of fun, and we got really indulgent. Also, our graphics artist kind of got carried away with some of the scenes too. So I hope you guys enjoyed. I'm going to go ahead and screen it, and then I'll talk a little bit about it afterwards. Okay, thank you, thank you, thank you. I would love to take all the credit for this, and I am an egomaniac, but I have to call out two specific people that help with this. First is Patrick Letourneau. He's our visual effects artist. This was about 2 weeks of his life. I think he slept maybe 10 hours in that 2 weeks. And then the lovely voice you heard is Deanna Moffats. She's a professional voice actor. You can hire her online. You can't hire Patrick. He works for me. But Deanna did a really great job. And it turns out when you're searching for voice actors, it's very hard to find a female voice actor that isn't just pre-programmed to be a soccer mom. She told us she was really excited. She doesn't often get a project where she isn't just supposed to be, the happy, perky soccer mom. We wanted kind of the fragility of a female for that voice, and the main character for the game is actually female as well. So I had a ton of fun doing this. The music's great. This is going to be online later. The website you see at the end of this is not set up yet. We're going to announce this in a couple days once we get that set up, but I really wanted you guys to get a peek of it before that. And so my closing thought, I want to come back to what Apple did last week, recognizing the Mac. I love iOS. I like developing for iOS. It's given me a career that I did not have before, but my first love has always been the Mac. And what I did, what I showed you, the fidelity of the music that you can do, that's only possible on the Mac. The people that built the Mac and then the people that are using the Mac to do that, there's just a vibrance in that community that allows us to do something that I dreamed about as a boy. The ability to just be surrounded by an orchestra that was just at the command of my hands. Plugged into this computer, I was editing this on the plane on the way here. I mean, how cool is that? 20 years ago, someone would be sitting in a studio with 80 to 90 people trying to do something that I could do just by dragging my mouse around. And that's all thanks to the Mac. So thank you guys very much. I had a lot of fun showing this to you guys.
Okay, well, we have just a few minutes here for questions here from the audience. So
Too long?
I know I have a few that I'll be getting to at some point, but please. Yes, we need the microphone on the back here.
Hey, Rob, when you're building a trailer or putting together a trailer for an app, would you select the music first and then do the video editing to match the music and the mood of the music, or do you do your video first and then try and find music that matches?
There's a planning stage that goes into it, and usually when we do an app, and we've done some app videos for briefs, the first thing you do is you put together the things that you want to do. You come up with a shot list, or the equivalent of a shot list, and then you talk about the rough things that you want to do, and then you kind of put it in a rough sequence, and then you go and find, and what you want to do is in that sequence, you want to leave time ahead of that sequence and time behind it. And then what we would do is we would go and find a piece of music. You kind of create the beat structure or rewrite it specific to that. It depends on whether you're using pre-built audio or you have a lot more flexibility when you're writing the music. So in the case of the video I showed at the end of this, we had a pretty tight edit before I wrote the music. But in the case where we used the pre-built music, what we actually did is we got it rough, we got it put together, and then we got the music, we kind of broke down the beat structure, and then we sequenced things and did those real fine grain edits to tie it to the music. But that step is crucial. It's not as easy as just saying, you know what, I record a screencast and I put a piece of music behind it. It'll work, but you're going to lose that effectiveness. You really want to tie visual events with audio events to get the best effect.
Okay.
Rob, do you have any experience outputting Logic Pro to a sheet music like a software like Sibelius or something like that? Does that?
I do not, but that's something that I'm looking forward to doing. Before, when I composed in college and in high school, I used Finale, which was the predecessor to Sibelius, and similar and different in different ways. But Logic is very good. Some of the MIDI sequencing was tough, and what I haven't figured out yet is, do I just not know enough about Logic to do that, and I know how to do it in Sibelius? But as far as outputting the sheet music, it's not something I've looked at yet, because for me, I feel like the patches and the plugins are good enough that I don't necessarily need it to be performed afterwards. Like I want it, you know, these pros, these people that do it for real, and for movies and stuff like that, this is like a mock-up tool for them. You know, what I just presented would be a prototype, and then they would go and have it performed live, and they would record it and produce it. So I imagine there's got to be something that gets it from that, because most of the tutorial videos I saw on Albion's site, they used Logic as their DAW.
Okay, thank you. I was wondering, Rob, are you doing an audio soundtrack for the game? And if so, are you using the same kind of technique for it as you demonstrated here?
Yes. This was a dry run. You know, it was really to prove myself, like, now that we're starting the game, starting to get more serious, it's like, okay, can I really do this, or is this just a crazy idea I have, and what's involved in it? And so this was kind of a dry run for that, in a way. Again, sorry, Tim, it was totally planned, but yeah, it was a dry run.
I'd be interested to see how that works out then. That sounds pretty promising. Anything else from the audience?
Yeah, I have a question here. So actually, Rob or Greg could both address this. So you've got, Rob, you seem to be generating audio files to use in your game, but you have these virtual instruments that are used in Logic. Have you thought about just programming the instruments in your game?
In the game?
Yeah,
or?
to play, for example, MIDI inside your game. Apple had a great example a couple years ago where they showed a MIDI song being kind of modulated as you went up a hill and went down a hill in a car, and that would give you more flexibility. I mean, I was thinking to maybe have a smaller game, you know, smaller files, or just
I haven't
things.
thought, it seems like the game would need to be musically geared to do that, but it takes a lot of, so I may be answering the wrong part of your question, so tell me if I'm wrong, but the transcoding from MIDI and then running it through these plugins is a very expensive operation. So if I do a lot of editing in Logic, I think I've got about 30 tracks in there that are running. Without freezing those tracks, and when you freeze them, it basically just outputs it to a sound file. If you have it interpreting all of that MIDI at once, it'll bring a brand new Retina MacBook Pro to its knees. I mean, you use a ton of memory that way, and I don't think that's Logic being a hog. I think it's an expensive operation because it's got to do all this interpretation, and then it's got to load all of those voices from those samples. And I mean, I'll watch it load sometimes. I mean, one of those instruments is about 200 to 250 megs of memory just to load that voice into the computer. So you multiply that by 30, you've got 6 gigs right there. If I did my math right.
One way that people cheat it a little bit is by using the same tempo throughout the game, and then they just take the stems that are pre-recorded and crossfade them. So you could get different emotional pieces of music and then bring one in, but by keeping the tempo the same, you know, it's easier to blend them.
Yeah, and I've seen some people that use Ableton Live. That's a lot of composers for games will use that, and what they do is they just create these different scenes in Ableton Live, and then when they have those mood switches, they just kind of switch into that. But they build them. But I mean, that's a craft in and of itself that I'm still trying to dissect.
So just to follow up, if you were to look at, I mean, you don't have the product yet, but to project how much space is used relatively by code, by graphics assets, and by audio relative to one another?
I would say, I know on the CGI side, we've got this is about a minute 45 of video. My graphics guy bought an external SSD to store this stuff because you really need fast access to this to edit it. And he filled about 120 gigabyte file just for the graphics. I have about 20 gigabytes. Well, my output is very small, but then I have about 200 gigabytes in these sample files that that right now I just keep on my MacBook Pro because I'm crazy and I have the terabyte drive, but eventually it's going to have to go on an external SSD.
It's a great idea, though. I mean, to make a game, and it doesn't even have to be around that idea, but to use dynamic music in some way. And if you're generating stuff, It's like vector images versus raster images.
Yeah.
You're trading processor for storage.
Yeah.
So if you want to generate your graphics on the fly using vectors, it's going to be more CPU intensive, but you're not going to use any memory. So it's the same with audio, but you could do some really interesting things by synthesizing the sound in a game and changing everything about it,
Yeah.
changing the mood, the tempo.
I mean, I'm making trade-offs. I have all these samples because I wanted that kind of orchestral sound.
Right.
You know, and there's just a lot of instruments.
And
that's
it's hard
playing.
to not make that sound cheesy when you're
Yeah, it's
synthesizing.
hard. It's hard to break it down. What I thought was interesting about what you did is, I want to have like an iOS instrument that I could compose on. Like Logic Remote and GarageBand are pretty close to that, but I think there's some interesting, especially just, you know, sometimes I just want to figure out a chord progression for something.
Right.
Like I don't even need the melody, I don't need the rhythm. I just want to know, you know, what's my chord progression and playing with mood.
I mean, the idea behind Polycord was kind of, you know, that all these desktop apps are very grid-based, very structured, and that a touch device opens you up to completely new ideas for how you
Yeah.
can interact with it. So, I mean, there's a lot of interesting stuff coming out, but it's
Yeah, like
huge
the
unexplored space.
dulcimer was in the
Right.
60s. Like I'd like to see something like that.
Just maybe a comment, but there's also libpd, which has more of like a visual interface for programming. So we were talking in other previous talks about visual programming. Libpd is, you know, you're basically just
Are you
taking
saying
components.
pure data?
Yeah,
Yeah.
yeah, exactly. So that's another, like, if you're going to synthesize music on the fly, maybe not for violins and things, but for sound effects or
Right.
spaceships and things like that, it's pretty easy to get stuff. And that's also cross-platform stuff that'll work on Android as well.
And that comes full circle to Bill this morning, because pure data, which is very similar to Max MSP, which a lot of electronic musicians use, it's a pinball construction set for making audio. I mean, you have these little widgets that you can connect in different ways. Those kind of environments are really interesting.
Well, and audio engineers are hackers. Like
Yeah.
that's, you know, you look at Ben Burt in the 70s, like I have this giant book. I'm a Star Wars nut. And the audio that he did for that, how he created those different sounds and what he did. And I mean, he's just like traveling all over the places and then just taking sounds and playing them back and reversing them and playing them on top of each other.
It's a good excuse for taking a lot of vacations. And
Yeah,
sampling sound.
and it's, yeah. And but it feels like that raw programming, kind of that, you know, Paul Graham hacker aesthetic.
Right.
You know, where it's very just trying stuff to see if it works. And nope, that didn't work, try this. No, modulate this. Oh, that
Yeah,
didn't
I mean,
work.
to me, some of the noises that would come out of my computer when I was making Polycord would, scare my wife. You could really blow out your ears, but sometimes you make something and you have to record it because you don't know what you did to cause that to happen. But
Your
you
Indian
think,
drum example, that was so much fun.
right? And you make stuff like that, and then you just have to keep a scrapbook of it because you can't recapture that magic sometimes. And back in the synthesizer days, it was cables that you'd never plug in exactly the same way again. So there is this kind of magic that happens sometimes, and it's fun.
So I just had a follow-up comment on the notation question in Logic. I found it mainly just helpful to get a different view on the music. So sometimes I want to just look and see, okay, I want some quarter notes there, half notes. In terms of producing sheet music that musicians can play, personally, I don't think it's very capable for that. But what you can do, as compared to Finale or Sibelius, but what you can do, I believe you can export in a format called Music XML, and you could also export the MIDI. I believe you can export the MIDI format.
Yeah,
I've never
you can
done
export
it, but
the
I would.
MIDI.
And then import that into Finale or Sibelius, and then generate your sheet music. So.
All right, and the last one, I guess. These guys will be around all week, though, so if you have more questions, I'm sure they'll be happy to answer them.
I can be bought off with all kinds of presents and gifts.
Yeah, my question is, you create this great music and $100,000 worth of studio equipment that are going to be played out of $1 speakers on an iPad or iPhone. What, if anything, do you do with the music to account for the fact that you're going to be playing it out of a much lower dynamic range quality speaker than you're actually producing it in?
But it can be plugged into nice speakers.
Yeah, I would say the funny thing you said about this, and I noticed this, is that the hall that we're in and the way it was produced, like the low drums that I had when the missiles were approaching got destroyed in this room. And so I think it's not just cheap speakers, it's the challenge with writing music that you know is going to be played on iOS or it's going to be played in that environment is knowing that it's going to be different environments. But I mean, I'm going to pimp Shure here. I have, $300 Shure headphones that blow the doors off any speaker I have in my house. And to the point where I couldn't master through those because I would master them and they sounded great on that, and then I would play them somewhere else and
in a car.
it's not as good. Yeah.
You always have to play it in the car.
And so it's essentially you buy monitors. These high end, and I mean they're not that. I think I paid $100 for a pair of Sony monitors, and they don't sound that good. I wouldn't want to listen to music through them, but if you master in that, they have such a frequency response that when someone else listens to it through different headphones, it's just using an audio signature that they're used to. It's like a way to normalize your audio in such a way that whether it's a crappy speaker or a $12,000 pair of, Boston or loudspeakers or whatever, it'll be good. I don't know if that answered the question.
All right, thanks. And just before we go, time to pick some prizes.
All right. Steve Weller.
Steve Weller. All right.